We are now on question number 5, 6.2 exercise. What's the information given first? There is a figure, as you can see below, where DE is parallel to OQ. So let's highlight in those points I'm talking about. This is DE, and this given parallel to OQ. Further, even DF on the other side, this line DF is given parallel to this side. So OR. And finally, we have to prove that is EF. This is parallel to QR. So in geometry, one very important thing is that every information given in the question has application in one other part of the sum. So let's use the first information. That means this one. Let's highlight in the triangle we are talking about. The triangle in which ED is parallel to OQ has to be this one, right? Now, as we know that in a triangle, if a line is parallel to one side of a triangle, then it divides the other two sides in the same ratio. So we can say in triangle, this is POQ. What do we have? We have ED being parallel to OQ. So therefore from BPT, we can say that it will divide the other two sides in the same ratio, as you must be knowing that this over this is equal to this over this. That is from BPT. So we can write here that is EP over EQ will be equal to the other ratio, that is PD upon DQ, and that is from BPT. This is by BPT. We can mark this as equation 1. Now we'll consider this time the other triangle. Let's see, the triangle here I'm talking about is the other one. Say this triangle. Yeah. So in this triangle, we can, let me write down the triangle. This is POR. Here too, DF is given parallel to OR. Therefore, applying BPT, what we can say that PD over DO is equal to PF over FR. Same reason, that is BPT. And this is equation 2. So when you compare equation 1 and 2, what do you see here in equation 1 and 2? Let's make some space here. This is what we got. Now, from equation 1 and 2, what do you see from equation 1 and 2? From equation 1 and 2, we can see that here the two sides, that is PD and DO, right? Let's understand once again. The first relation we have PE over EQ is equal to PD over DO, right? Let's say this is DO. Once again, this over this, right? EP, ratio of EP to EQ is same as PD to DO, and ratio of PD to DO is same as PF to FR. So what do we conclude here? That from these two equations, we can write the remaining parts as equal. That means this should be equal to this. That means EP over EQ should be equal to PF over FR. Now, as you can see, this relation I'm talking about in triangle, in this triangle, the biggest triangle here. The triangle here, I'm talking about this one, the largest one. Now consider this triangle. Now, in this triangle, what do you see here? What we have proved as of now, that this over this is equal to this over this. So we can use converse of BPT. And what is converse of BPT says that if a line divides the other two sides in the same ratio, then this line will be parallel. So here, this will be parallel to this. That's from converse of BPT. So from here, you can write by applying converse of BPT. That is converse of BPT. We can say that EF is parallel to QR. And that's how it can be proved.